So let's integrate a given function, which is sine of 2x all over cosine squared minus cosine x raised to 4. Now, if you're going to integrate this problem, the first thing that you will do is that maybe you could use a u substitution or algebraic substitution. Maybe we will let u as cosine squared x minus cosine x raised to 4, you know, or maybe just simple as, u cosine. However, if you're going to use that, that wouldn't work at all. So here's what I'm going to do here. So first and foremost, I will factor out the expression here by cosine squared x. So as a result, we will have quantity 1 minus cosine squared x times cosine squared x. All right? Then I'll copy sine of 2x. Then in here, let's recall our Pythagorean identity in trigonometry where sine squared x is just the same as 1 minus cosine squared x. Therefore, we can simply rewrite this lo- excuse me, we can simply rewrite the 1 minus cosine squared x as sine squared x times cosine squared x. All right? Now, you see, in here you may be thinking that maybe we could use algebraic substitution or whatsoever, but if you're going to still use that method, it wouldn't work at all. All right? So the best thing that I'm going to do here is I will still continue simplify. So how can I simplify in this case? Like, should I convert them into tangent or maybe into different trigonometric function? Well, it's not that actually. Well, you see this sine of 2x. According to double angle identities, sine of 2x is just the same as 2 times sine x times cosine x. Right? So let's rewrite this sine of 2x as 2 times sine x times cosine x. All right, then we have sine squared x, cosine squared x. In here, we can now simplify because here we have sine x, cosine x, and sine x and cosine x in denominator. I mean, like, we have sine x and cosine x on both sides, basically. So what happens is that on the top, sin x will be cancelled, and then the exponent here in the sign below will be reduced to 1. So we will have sin x. Likewise, for cosine x, we will cancel cosine x, and the exponent here will be reduced by 1. As a result, we will have cosine x. Also, we have a constant multiple of 2. It acts as a coefficient, so we can just bring it outside. That's according to constant multiple rule of integration. So therefore, we will have 2 times the integral of 1 all over sine x times cosine x dx. Now, you may be thinking, maybe can we, what do you call this one? Can we now integrate it? Well, no, because the thing is, if you're going to integrate this one, you will not able to use substitution or you will not be able to use other methods like trigonometric substitution and so on and so forth. All right? Or maybe you might be thinking, maybe let's just uh, convert these two trigonometric functions into its reciprocal identity. Remember that 1 all over sine x is just the same as cosecant x. And for the for the cosine, sorry, for cosine, we will have secant. So, okay, let's just say we do that. All right, like we have 2 times the integral of cosecant x, cosecant x times secant x. Okay, but how are we still going to get the integral from this? All right, maybe use substitution? Well, no, that's not the case. So what am I going to do here? For us to get the problem is simple. So what I'll be doing here is that I will convert sine x cosine x into sine of 2x. That is what I'm going to do in the denominator. All right. So how can I do that? I'm going to put a fraction beside it, and that fraction is 2 all over 2. So this is the case. All right. Now, after that, the what was one? The two above and the sine x and cosine x, I can combine them all together. So we will have 2 times sine x times cosine x all over 2 dx. All right. So with that, I can now change sine of 2 sine x cosine x here as sine of 2x. Therefore, this would become sine of 2x all over 2. Now, we need to simplify this fraction because as you can see, this is a complicated fraction. So what I will be doing here is I will have 1 times 2 all over sine of 2x. Right? So in here, I will have 2 as a constant. So I can just bring it outside and combine it with 2. So if I bring 2 outside and combine the 2 outside, I will have 4. Then the rest, I'm just going to multiply them together. So I will have 1 all over sine of 2x. Right? And then here, you see, I will convert sine of 2x into cosecant of 2x because remember, according to the reciprocal identity, that 1 all over sine x is just cosecant x. Therefore, if I have 1 all over sine of 2x, I will have cosecant of 2x. All right. Now let's get the integral for this. In here, you see there is a composite function. Like we have a tangent function, then we have another function within that trigonometric function, which is 2x, an algebraic function. So we will use algebraic substitution. I will let u as 2x. Then we will get the derivative of your u. So as a result, we will have 2 then dx. Then I will use this equation to find my dx. All right. So what I will do is I will divide both sides by 2. So as a result, I have 1 half of du is equal to dx. Now let's substitute here. So what I will have is cosecant of u times your dx, which is 1 half of du. We have 1 half here, so I can just bring out outside. Again, that's based from constant multiple law of integration. And once we bring 1 half outside, we will multiply it by 4. So 4 times 1 half is simply as 2. So we have 2 times the integral of cosecant u. So how can we get the integral of cosecant u? So remember that if you're going to get the integral of cosecant function, wait, let me take a look. All right. If you're going to get the integral of the cosecant function, this is ln of cosecant x minus cotangent x, right? Plus c. Therefore, we will have the answer of 2 times ln of cosecant x minus cotangent x, right? Plus c, right? Oh wait, it's not x by the way, it's u, right? It's u. There we go. Cosecant u. All right, and there we go. So let me just distribute 2 here. I mean, I'll combine 2 in this function. So yeah, there we go. So are we done? Nope, not yet. We still need to do one more thing. We have u, right? U is what? 2x, So we will bring back that. So the answer for this problem is ln of cosecant of 2x minus cotangent of 2x. All right, there we go. We can leave this as your wait, we can leave this as your final answer, or we can still simplify this. The only thing that we're going to simplify is the logarithmic function, which is this one, you know, because here, according to the law of logarithm, where if you have ln of a raised to n, where n acts as an exponent of your argument or the input of the ln, we can just simply bring down that exponent. So we will have n times ln of a. So this is what you call the power law of logarithm. All right. And likewise, we can just simply bring what's beside ln up and act as a exponent for that function. You get me? So therefore, I can just bring 2 as an exponent for this one. So we will have ln of cosecant. Wait, let me just rewrite this properly. right? Ln of cosecant of 2x minus of cotangent of 2x squared, then plus c. And that is our final answer.